So hello, emergent properties. That's the topic of today's video. I think not the easiest topic to explain, but in my view, a very interesting one. Well, multicellular organisms like humans and other animals and plants, they show something that we call emergent properties. And what is that? Well, there is this really famous guy over here. I don't know if you recognize him. His name is Aristotle. And he once used to say the following. He said, the whole is more than the sum of its parts. Look, the whole is more or is greater than the sum of its parts. In other words, he didn't know much about cells at that time, but when we talk about biology, a human being is just more than a whole bunch of cells just thrown together. Obviously, like, I don't know, a car is more than just an engine, four wheels, and I don't know, doors and seats and a steering wheel. The parts have to work together, and when the parts work together, then the organism is able to do things that single-celled, unicellular organisms are not able to do. I want to give you an example here. For example, my brain contains billions of nerve cells, brain cells, and together, they work together so that I can think. So the ability to think is an emergent property which cannot be found or which cannot be explained by analyzing the nerve cells in my brain separately. You can only try to understand what thinking is, or what personality maybe even is, or what memory is by looking at all of the nerve cells in my brain. And I will not be able to find the memory that I stored in my brain by analyzing the individual nerve cells. No, of course it's not possible. The parts have to work together. And I just want to show you something over here. A classic example of an emergent property in nature. This here is the colony of a termite. It's a termite colony, a termite mound. They're huge, several meters in size. There are millions of termites, basically made this colony, and they are extremely complex. You see, termites, they use a lot of oxygen, of course, so they have to have built in some kind of a ventilation system so that there's a natural airflow in the channels in this termite colony, so that there's always a sufficient oxygen supply and the temperature has to be right. And the termites, millions of them, they build those termite colonies. And it's very complex in the design. But you know what? If you look at one termite, where in this termite, how does it know how to make something like this? Where can I find the building plan, the construction plan for this colony here? I won't be able to find it anywhere. So this termite mound is an example of an emergent property which arises and emerges when millions of single parts work together. I want to give you another example. I don't have a picture of this now, but all of you know that on the ocean shore, when there are waves in the water, then there are the ripples in the sand. So basically there are ripples in the sand, and also sand dunes are like gigantic ripples. Now, how do the sand grains know how that they're supposed to make those ripples? How do they know that? Well, they don't. These ripples appear due to the interaction of the air and the wind, and this is also known as an emergent property. Over here I've got a little definition of an emergent property. These are multicellular organisms display emergent properties, and these are properties that appear when different parts of a system interact with each other. So they have to interact, and that is a very key point here. Simply throwing a whole bunch of cells together won't make a functioning multicellular organism, obviously, but the parts have to work together. And then those multicellular organisms are able to do things that single-celled unicellular organisms are not able to do. Okay, and I'll leave it at that. Wish you a nice day. Bye-bye.